everyone, and at the end of this video we will be able to divide an algebraic expression by an algebraic term. Let's start with simple examples, from simple to ordinary examples. Let's continue. X power of 5 divided by x squared. So here, as you see, x power of 5 is less than the power of x on the numerator is less than the power of x on the numerator. If you know how to do operation with exponential number, when you divide two exponential number, you subtract the power. This is equal x power of 5 minus 2. We subtract the power is equal x power of 3. If you don't know that one, let me show you how we solve that. Let's choose a pen. Yeah. So x power of 5 is x multiplied by x multiplied by x multiplied by x 1, 2, 3, 4, 5x divided by x squared x multiplied by x. So we have to simplify. X and x, they cancel each other, 1 and 1. X divided by x, so we can simplify them by x, again 1. What we have here, we have x times x is x cube. This is equal 1 times 1 x cube over 1 times 1 1. Sorry, not x squared, x cube over 1 times 1 1. So 1 times x cube is x cube over 1. It's equal x cube. X cube divided by 1 is x cube. We can say that much. So v5 minus 2 is 3. X power of 3 is result. Look at that one. How can we solve it? Again, 2 minus 5. This time x power of negative 3. So it will be x power of 2 minus 5. It's equal x power of negative 3. It's equal 1 over x power of 3. Yeah, it's a long process. Let's clean that one and continue. Let's show how it's worked. This is x squared is equal x times x over x power of 5. X multiplied by x multiplied by x multiplied by x multiplied by x 1, 2, 3, 4, 5. Yeah, that's right. Let's simplify. X simplified by x, you can simplify by x, so 1 and 1. X numerator, x at the denominator, you can simplify by x, so 1 and 1. What we have here, x multiplied by x multiplied by x, it's equal x power of 3. So 1 times 1 is 1 over 1 times 1 1. 1 times x cube is x cube. So 1 over x cube. So at least I can say we can subtract the power here again, but which power is greater than the others, we can write the result on that side. For example, numerator, power of numerator, x power of numerator is greater than x power of denominator. Sorry, x power of denominator is greater than x power of numerator. So 5 and 2. So 5 minus 2 is 3. As you see, stay denominator. Here, x power of 5 is greater than x power of 2. It stay numerator. So you can subtract the powers all the time. It will be a short cut. You don't need to write all the time multiplication. Okay. Let's use that one here. That information, let's use it here. But here coefficients 12 and 8. 12 over 8 is a fraction. We can write as a simple form. 12 divided by 4, 8 divided by 4. We can simplify by 4, both of them divisible by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. 3 over 2. Let's do the operation here. X cube and x power. If there is only x, we know the power is 1. 3 minus 1, 2. So x squared. Because 3 is greater than 2, x squared will be there at numerator. This is equal 3 times x squared, 3x squared over 2. So this is the simplest form. You can write it 3 over 2 x squared. 3 over 2 as a coefficient. It's okay, that's true. Both of them same with different notation. Let's check the second one. Again we can simplify 8 and 20. Again we can simplify by 4. Okay, interesting. 8 divided by 4 2. 20 divided by 4 is 5. Let's check the variable. We have x. If only x, the power is 1 here. X power of 6. As you see, x power of 6 at denominator. 6 minus 1, 5. X power of 5 will be at denominator. Let's continue. 2 times x, not x this time, because we subtract it, so this will be 1. Instead of that one, it will be 1. 2 times 1, and it will be 2. Where is the black color? Sorry. 2 times 1 will be 2. I cannot choose the black color, as you see again. 2 times 1, 2 over 5 times x power of 5, 5x power of 5. So this is the simplest form. But you cannot write that one as the second form, because denominator, the x power of 5 denominator, 2 over 5 is coefficient, but here 1 over x power of 5 we have. If you want to separate 2 over 5, multiply by 1 over x power of 5. But simplest form is that one. This is again, there's a multiplication between two term. Okay, let's continue. At least we can subtract the numbers and write the result at numerator or denominator, which power is greater. This place of which power of greater. There is another example. As you see, this time we have two different variables. So when we simplify, we can exploit common variables or like variables. As 12 and 9, they are divisible by 3. 12 divided by 3 is 12 divided by 3 is 4. 9 divided by 3 is 3. This is first. Let's x power of 5 x square. So power of 5 is greater than x power of square. This will be 1. 5 minus 2. This will be x cubed. 5 minus 2 is 3. And y, the power is 1 here. Y square. So this will be 1. 2 minus 1, 1, only y. Y squared divided by y is y. We don't write y power of 1 usually. It's only y because. Okay. We simplify it mentally. So it will be equal 4 times x squared, as you see, x cubed, sorry, 4 times x cubed and y over 3 times 1 is 3. So this is the simplest form. Instead of that one, 4 over 3 coefficient x cubed y, we can separate. It's at the numerator. The variables, all the variables at the numerator, we can separate like that. Let's continue. 1 over 9. We cannot simplify. There is only 9. There is no coefficient, so we cannot simplify. Let's continue with variable x squared x power of 4. X power of 4. So the greatest power on the denominator, so this will be 1. X squared divided by x squared is 1. X power of 4 divided by x squared, so 4 minus 2 is 2. X power of 2. Let's check the y. Y power of 1, y cubed. 3 minus 1 is 2, so y squared, this will be 1. It is equal 1 times 1, 1 over 9 times x squared, y squared. 9 multiply x squared, y squared. This is the simplest form of this division. Quotient of the division, maybe you can say. Oh, there is another one. 18 and 12. Coefficient x cubed, y power of 5, z squared, x power of 4, y power of 3, z. There are lots of different variable. Let's first start with coefficient 18 and 12, both of them divisible by 6. 18 divided by 6 is 3. 12 divided by 6 is 2. Then let's check x power of 3, x power of 4. Power of 4 at numerator, so I can simplify power of 3. X power of 3 divided by x power of 3, 1. So x power of 4 divided by x power of 3, 4 minus 3, 1. So x, only x left. So continue with y power of 5, y power of 3. Y power of 5, y power of 3. 3 is less, so this will be 1. 5 minus 3, 2. This will be y squared. And there is z squared divided by z divided by z, 1. Z squared divided by z is only z. So let's write everything here. 3 times 1, 3 multiply by y squared multiply by z over, over 2 times x times 1 times 1. 2 times 1 times 1 is 2 and 2x. This is the simplest form. We simplified or we divided. What do you want to say? It's okay. Okay, until now we divided term by term, as you see, term by term, term by term. So term by term, we simplify term by term. Let's come to an algebraic expression by an algebraic term. So we will divide this algebraic expression by this term. So we can write this like fraction. Let me show you some things about fractions. We all know a over b, any fraction, plus another number c over b. Denominators are same. We can write it a plus c, sum of the numerator, over common denominator. If you think that's equal, so I can separate if there is a number a over c. If we talk about two numbers and common denominator, we can separate with this common denominator, a over b plus c over b. Let's make an example. 5 plus 2 over 3 is equal 5 over 3 plus 2 over 3. I can separate it with common denominator. I will use the simple fraction. I will use this simple fraction rule to calculate this division or this divide expression by a term. I will use this rule. How I can use it? I will use first term. You don't need to write all time. Of course, you can do it mentally. Over 2x cubed y cubed. First term over denominator plus second term x cubed y power of 5 over 2x cubed y cubed plus third term x squared y over 2x cubed y cubed. So as you see, I have two different terms. So I need to simplify term by term, term by term, term by term. Let's do it. Let's do the first one. Start from the first one. Let's continue step by step. 2 divided by 2, 1. X power of 5 x cubed. This will be 1. This will be x power of 2. Previous examples we did that part. Y square y power of 3. Sorry, I wrote here 2, but it must be 3. Be careful. As you see, cube y cube. It must be same denominator. We cannot change denominator here. So let's continue. Okay. X power of 5 x cubed. This will be 1. 5 minus 3 2 x squared. 4 minus 3 1. So only y is here. Y cubed will be 1. Y cubed divided by y cubed is 1 because of it. 4 and 2. 4 and 2 we can simplify by 2. 4 divided by 2 2. 2 divided by 2 1. X cubed and x cubed. X cubed divided by x cubed 1. We can simplify by x cubed 1. Y power of 5. Y power of 3. 3 is smaller. This will be 1. 5 minus 3 is 2. Y squared. 6 and 2. We simplify by 2. 2 divided by 2 1. 6 divided by 2 is 3. X squared. X cubed. Square is smaller. This will be 1. 3 minus 2 is 1. So only x power of 1 or x. And y cubed. Again, y is smaller. 1. 3 minus 1 is 2. Y squared. So I make the simplification. Let's write it. 2 divided by 2 1. These are 1 if you remember. 1 times x squared plus y. It's x squared multiplied by y. On the denominator 1. We have 1 denominator. Plus 2 times 1 2 y squared. Because 2 times 1 2. 2 times y squared 2y squared. 1 times 1 times 1 over 1. Plus 3 times 1 times 1 3 over 1 times x times y squared x y squared. Here of course you can, the denominator is 1, we don't have to write it. Any number divided by 1 itself. X squared y plus 2y squared plus 3 over x y squared. This is the last algebraic expression. When we simplify all these algebraic expressions by this term, we will get x squared y plus 2y squared plus 3 over xy squared. Of course, these take lots of steps here. I need to lock it here. Let's lock. I will cut every other things here. Sorry, I couldn't choose all of them. Yes. Now, let's do it mentally. Let's don't write all these steps. Let's do it step by step on the algebraic expression. First, I need to simplify that algebraic expression, that one, and I will write directly here. 2 divided by 2, 1. When you simplify 2 and 2, it will be 1. Let's keep in my mind. We have my 1 in our mind. Let's write here 1. X power of 5, x power of 3. This will be 1. This will be x power of 2. So y power of 4, y power of 3, y cube. This will be 1, 4 minus 3, y power of 1. It's y power of 1 is y. So that we get that 1 times x squared plus y. We have 1 in our mind. 1 times x squared plus y, x squared plus y. Let's write it. X squared y over 1. 1 times 1 over 1. X squared y. This is first term. Let's continue with the second term. Think this all process in your mind. Let's do the second one. 4 and 2, x cubed divided by x cubed. When you simplify common same things, these are going to be 1. So y power of 5, y power of 3, 5 minus 3 is y 2. This will be 1. Let's write that one. This is positive 2 plus 2 times 1 times y squared, 2y squared. 1 times 1 times 1, 1 over 1. I am not going to write over 1. Any number divided by 1 is, of course, the numbers itself. So 2y squared, or any term divided by 1, the term. This is the second term for quotient for result. Let's continue 6 and 2. 6 divided by 6 and 2 we can simplify by 2. This will be 1, this will be 3. So x squared, x cubed. Here be careful. Okay, x squared, x cubed. So cube is bigger than x squared. 3 is bigger than 2. So x will be stay here. 3 minus 2, 1, x. Y and y cubed. Y power of 1. Don't forget, if there is nothing, only 1. That's power is 1. 3 minus 1, 2, y squared. So let's write that one. 3 times 1 is 3 over, because 1 times x times y squared, x y squared. So as you see, we can do it mentally. We don't have to write all these steps. We don't have to write all the steps. We get the same result. Sorry, let me choose that one and put it up to it. It's they are equal, same things. So we can do it mentally. One term by term. You need to simplify all terms by this denominator. Okay, this is the last example. 15 and 5. We can simplify 15 and 5. Let's change the color to make it more clear. 15 and 5 we can simplify by 5. This will be 3. This will be 1. X power of 7. X power of 2. So 7 is bigger. 7 minus 2 is 5. This will be 1. Y and y power of 5. Y power of 1 is here. 5 minus 1. Y power of 4. This will be 1. Let's write it. 3 times x power of 5. 3x power of 5 multiplied by 1. 3x power of 5. 1 times 1 multiplied by y power of 4. Plus. So we need to do this operation for all terms. Don't forget, only one term is not enough. Let's continue with the second term. Minus 40 divided by 5 minus 8. So you can simplify by 5. Minus 40 is divided by 5 minus 8. 5 divided by 5, 1. Let's write it. X cubed. Let's continue with that, no problem. X cubed and x squared. So 3 minus 2. This will be x. This will be 1. So 5, y power of 5, y power of 5. Both of them will be 1. Let's write it. Minus 8 times x times 1. Minus 8x. So I wrote here plus, but it's wrong. It must be minus, because we have minus 8x. Over 1 times 1 times 1. Minus 8 over x divided by 1 is 1. So we don't write this one. Okay, clean it. Let's continue. 20 and 5. I can simplify by 5. 20 divided by 20 and 5. Both of them divisible by 5. 1 and plus 4. Don't forget, this is a positive 4. x square and x square, this will be 1 and 1, y power of 5 and y power of 1, there is nothing, it's 1. So this will be 1, this will be 5 minus 1 for y power of 4. Let's write it. So positive 4, don't forget, 1 times y power of 4 on denominator, 1 times, so let's clean that one first, because let's move it a little up, don't clean it, let's move it a little up. Okay, y, we have a denominator here, 1 times y power of 4, it's 4 divided y power of 4. So this is the simplest form. When you simplify it, we get that one. I don't know if it's necessary, but that's it. If you keep it that way, that's okay. You can write all of them on a common denominator, but it's not necessary. I think that's okay. Thank you for listening.